What's up, guys? Welcome back to another LeetCode solve, and today we're gonna be doing something new. I took all the problems I solved off the LeetCode website, and I copy pasted them here, and then I cleaned them up so it's just all the links right here, and I made a script that selects a random one. Well, Copilot made the script, but anyways, I ran it, and the problem I got today is this problem. So I'm going to start also randomly solving problems that I've solved before. But then I look at this problem and I don't particularly remember solving this problem, which could be an issue, but it's also an easy. But also, I looked at it and it looks like a dynamic programming problem, which I'm not particularly great at. But regardless, let's jump in. Today we're going to be solving LeetCode 746 min cost climbing stairs. So what this problem is saying is given an integer array cost where cost I is the cost of the ith stepped on a staircase. Once you pay that cost, you can either climb 1 or 2 steps. And you can either start with the step at index 0 or the step at index 1. And I want the minimum cost it takes to reach the top of the floor. And looking at this case, we want to start at the 15 because then we can just jump 2 and then be done. Yeah. But this one we don't want to start at the second one because that's a big cost. We want to start at the first one, jump 2, jump 2, jump 2, but then jump 1, then jump 2, then be done. That gets to 6 regardless of these 100 landmines over here. Well, let me look at that problem and see if I can come up with some sort of relation to do it. So we got 100, 100, 1, 100, 100, and 1. Because that doesn't look too pretty, but I'm sure that's fine. So I can choose to start at either of these. And I don't know. I don't know if doing this greedily is the way to go. It makes sense to be oh, let's start at the minimum one. And then we can choose to jump 1 step or 2 steps. I wonder if we just choose to jump at the minimum one, then that's fine. But then we do this one, and then it doesn't do the same. So it doesn't really matter. Or I could just see, let me see, because there's obviously there's not an infinite. It seems like there's a lot of things that I can do, but there's not an infinite amount of things I can do. So let me just see what my options are. So I can start at the first one, like here, right? And I either go to the 100 or I go to the 1 over there. And then from the 100, I can either go to the 1 or I can go to this one, and from this one, I can either go to this one or this one, and so on, so forth. I wonder if I can turn this into some sort of tree. Let's say we start at the 1. I can either choose to go to the 100 or I can choose to go to the 1. From the 100, I can either go to the 1 or the 1. And from this third one, I can either go to the 1 or the 1. But this kind of gets a little messy quick, because boom, I can go to this, or boom, or this or this. It's what I'm noticing is this one, which is that second, and this first one. These are the same. That's the same number. Well, the same index in the list I'm looking at. This is the previous one, and this is the next one. I guess if I continue this, we go to 1 and we go to 1. And this is the same one. And from that middle 1, I either go to 1 or I go to 100. And I guess that's the same here too. But from the third one, I can go to the 100 or the one after. And all three of these hundreds are the same. But this is difficult. I mean, I know that, like, these subtrees are also the same. And this one will have a subtree that's the same. And these hundreds will have subtrees that are the same. Like, there's definitely something I can, like, save on. I don't remember, like, anything about how to approach this or what the template looks like. Which is probably a good reason to do random problems like this. Well, I know I need a base case. And I know I'm, like, accumulating some sort of cost. Like, I wonder if I could set, like, some sort of table that's, like, the length of the cost array, because I want to, like, accumulate a cost across this. I know that. And I need a base case, so I know that I can start at 0 or I can start at 1. And that is true. And maybe for, like, each subsequent one, so for in range 2 to no, I think this is fine. Maybe I just do DPI is the minimum of what? I minus 1 and I minus 2. Because I know I want the minimum. I also know I can jump 1 step or 2 steps. And I know I want to accumulate. So I need to accumulate, so I need to, like, involve the cost of that step. Plus the... Wait, I think I might actually be on the right track here. Let me see what this looks like. Because I, like, need to... I pay a cost when I reach a step, but I also reach it from somewhere. So... Okay, so 6 is my answer here, and, oh, yeah, and then the second, like, I can either do 1 step or 2 steps at the end. So I think it's actually... I want to return the minimum of the last element or the second to last element. Bang. Bang. I kind of remembered I needed to accumulate something. So having this, like, set of ones, that's abstract there. It's the unit. Wow. I think this will submit. Okay. That's good enough for me. I think this is asymptotically correct. Oh wow, yeah. That's beautiful. I got this down to O of N. I mean, look at all these options. I got it down to O N. Cuz I started just, I don't know. I knew like this had something to do with it. And it kind of came back to me that I needed to accumulate something. But then I just kind of think about the problem, like I'm accumulating the cost at a step, and I can either go from one step before or two steps before, and I prefer to take the least one as I'm building this up. So this line here is just exactly doing that. And just remembering that you need a base case, I think helps a lot. So yeah, that's pretty good. So this is another thing I'm gonna do. Let's see how different. I think it's a worse solution than the one I probably got straight from LeetCode and didn't really think about too much. Oh, I use 0 here. Does that even matter? The rest of it's the same, is it? Yeah, it is the same way. How is this so much better? Is this like that much of a faster thing? Or is it just like some random like Python thing that I don't care about? Whatever. It looks similar enough. And I did actually come up with it on the dome. When did I solve? September. Wow. Okay. Maybe I'm getting better at this. If you enjoyed the video, please like and subscribe, and until next time, goodbye.